Well, they say we live in an expanding universe, but how do you know? I mean, I look around here, I look around my room, it doesn't look like it's expanding to me. So, how do we know we live in an expanding universe? I mean, there's some really good evidence that we do live in an expanding universe. Well, to show you the evidence that scientists have for an expanding universe, it'd be rather difficult for me because it would involve light, and I just don't have the facilities for that. So I'm going to have to use something that is very similar to light, but not exactly the same thing. We're going to look at sound. Now, when I say they're similar, I would say that because they both travel in waves. And I can show you the effect that they're looking for in light. I will show you in sound, or at least hopefully you'll be able to hear it and observe it. And this will all make sense. So, first of all, I'm going to use a tuning fork. And the great thing about the tuning fork is that when I strike this, it's going to emit a sound wave. And the sound wave is going to be the same size constantly, and it's going to travel at a constant speed. And because it works that way, if I can make the pitch change, then that means something's going on. And so here we go. Let's try this. Now, hopefully, you'll notice this constant pitch, but then when I move it towards the mic, you'll get a slight change in pitch. And we call this the Doppler effect. And what is happening is the sound wave is traveling in a waveform or sine form. As it approaches your ear, you hear it, it vibrates, and you hear it, and it sends a message to your brain, and you go, oh yeah, that's a high C there, or middle C. And as the tuning fork comes at you rapidly, what happens is that causes the sound to compress against your ear, and it causes a slight change in pitch. And as it goes away from you, the waves stretch out again, and that causes a slight change in pitch. And we call that the Doppler effect. And you may have seen this same effect if you've ever been near a train track and the train's coming at you, or maybe you've been sitting on the corner and all of a sudden here comes that 65 Mustang, with the 289 V8 and the 4-barrel carb. And as it goes past, you'll hear that change in pitch again. And again, it's the sound waves compressing against your ear and then stretching out, moving away. Now, the same thing happens in our universe when we look at light and look at stars. As you know, there's the Roy G. Biv, or the light spectrum: red, orange, yellow, blue, green, indigo, violet. And their shorter wavelengths give you certain colors, and longer wavelengths give you a different color. Now, if something was coming at us, it would tend to change the spectrum and shorten the light that we see looking through our telescopes, and we would see something more blue in color. But if the objects are moving away from us, like stars or galaxies, then their spectrums would be shifted sort of to the red and stretched out, because that's the longer spectrum. Luckily for us, as we look at different stars and galaxies and binary star systems, we see that most of the objects in our universe seem to appear to be shifted towards the red, which means, of course, that they are moving away. Hence, we live in an expanding universe. At least that's the evidence for it. So just remember, coming at you or going away, hopefully, the universe will continue to expand. And it's kind of neat to think that you live in an expanding universe.